This silhouette has been reproduced on millions of postcards and smartphone screens. A perfect archway against the backdrop of the clear Roman sky. A symbol of immortality frozen in time. We are constantly sold this image of eternity and immutability. But stone can lie.
If you stand at the base and run your hand over the weathered travertine, you will not feel the grandeur of architectural genius.
You will feel the traces of a desperate, centuries-long struggle for survival. What towers above us today is not a triumph of engineering. It is a maimed survivor. It was scorched by lightning strikes from the heavens. It was torn to pieces by seismic waves. It was gutted by looters who ripped steel tendons from its very core. By all laws of physics and the strength of materials, this building should have collapsed centuries ago. Because the Colosseum is not just an amphitheater or a stage for gladiators, it is a gigantic, overloaded mechanism for crowd control. An instrument of power that, from the very first day of its existence, operated at the limits of its physical capabilities.
By the end of this story, you will understand why this empty shell is still holding up, and what the real cost of its standing is.
But to understand the physics of this survival, we must return to square one, to an era when there were no tourists, no grandeur, and no ruins in this place. Only the stench of stagnant water, sticky mud, and the silence of the deserted imperial palace. The ground here was utterly unsuitable for the heaviest structure in the history of the ancient world. It was a natural lowland between three Roman hills, the Palatine, the Caelian, and the Esquiline. For centuries, water had flowed here from all over the city center, turning the valley into a swampy place. Emperor Nero, defying geography, transformed this lowland into an artificial lake for his private golden residence. In essence, it was a deep swamp, embellished with expensive marble and surrounded by luxurious gardens. When Titus Flavius Vespasian came to power after a bloody civil war, he faced a daunting political challenge. It was critically important for him to completely erase the memory of Nero and return this seized land to the common people. The emperor's solution was brilliant in its directness and audacity. He ordered the vast lake to be drained and an arena of unprecedented scale to be built right in its place. But the ambitions of the supreme authority instantly collided with the harsh physics of reality. You simply cannot place a cyclopean mountain of stone on liquid, unstable mud. Vespasian's engineers faced their first serious and nearly insurmountable obstacle.
The entire massive project required colossal weight, yet the local geology offered the builders nothing but emptiness beneath their feet.
Roman craftsmen were great builders, but even they could not defy the laws of universal gravity. However, they possessed sufficient knowledge and resources to completely alter the very structure of the earth. First, they dug an extensive network of deep drainage channels. These engineering structures forced the water to flow from the lowlands directly into the Tiber River. But even after that, the ground remained extremely unstable for construction. It consisted of loose alluvial deposits that had absorbed moisture from the soil for centuries. If they had begun erecting the amphitheater's walls directly on this ground, it would inevitably have split in two.
The structure would have sunk into the ground before the first tier was even completed.
In this situation, radical technical intervention was required. It was an uncompromising decision that ultimately cost the Roman Empire a fortune. Workers dug a circular pit of incredible dimensions. It was a gigantic trench, 50 meters wide and 13 meters deep. People worked tirelessly to dig through layers of mud to reach the solid clay layer. Only then were they able to begin pouring the main foundation. And this is where the first and most important secret lies as to why this colossus still stands the test of time. They did not simply fill the prepared pit with ordinary stones or stone blocks. Instead, they created a massive artificial monolith capable of withstanding any weight. The body of the amphitheater began to take shape through a controlled chemical reaction. They decided to use opus cementitium, which we know today as the famous Roman concrete. But it's important to understand that this is not at all the same material used to pour modern parking lots or sidewalks. It was a completely different, one might say, living substance with unique properties. The main secret ingredient in this mixture was fine volcanic ash from the town of Puteoli.
This material was called pozzolan and possessed remarkable binding qualities.
When this volcanic ash was mixed with lime and water, a violent exothermic reaction began in the vats. The mixture heated up extremely quickly and began to emit thick steam. The concrete didn't simply dry out in the open air like ordinary building clay. It began to crystallize at the deepest molecular level. Pozzolana reacted instantly with lime and water. This led to the formation of special minerals that, over time, became only denser and much harder. Workers dumped thousands of tons of heavy tuff and basalt into this boiling, constantly steaming mixture. This stone aggregate took on the entire future compressive load from the building's weight. The result was a 12-meter thick, solid, and virtually impenetrable monolith along the entire perimeter of the giant ellipse. This was not a conventional building foundation in the sense we are accustomed to. In fact, it was a single concrete pontoon that was literally dropped into the basin of a dried-up swamp. The Colosseum does not actually stand firmly on solid ground.
It literally floats on it, supported by its concrete cushion.
It is precisely this underground disk, hidden in the darkness, that will save the structure in the distant future. Many centuries after its construction, the continental plate will begin to shake violently from earthquakes. But the flexible and durable foundation will withstand these terrible blows of nature. The outward appearance of incredible stability was laid down by the builders deep underground. But the massive foundation is merely a heavy anchor for the entire structure. The main physical challenge awaited the engineers above ground, under the scorching sun. The scale of the amphitheater dictated its own ruthless rules. 3 monumental tiers of arches plus an upper attic, the total height of a modern 15-story building. It was impossible to erect such a structure using concrete alone. It would simply crumble under its own unbearable weight. The building required a powerful, external, and ultra-rigid exoskeleton capable of holding its shape. Thus, travertine appeared in the project, becoming the face of the great amphitheater. This is a snow-white and very cold limestone, mined by the thousands of tons in the famous quarries of Tivoli. This heavy and incredibly dense material was capable of withstanding colossal compressive pressure. Hundreds of thousands of tons of this travertine were transported to Rome via a wide road built specifically for this purpose. Each quarried stone block weighed between 2 and 7 tons. It was on the scale of a mountain range, which the architects brought right into the heart of the city.
But the engineers faced the challenge of how to make these disparate blocks work together as a single entity.
Traditional lime mortar was completely ineffective under such conditions. With the inevitable micro-vibrations of such a massive structure, the mortar would quickly crumble. As a result, the wall would irreversibly lose its original rigidity and strength. The engineers of the great empire made a decision that would determine the building's fate for 2,000 years to come. They completely abandoned the use of cement in the building's outer load-bearing ring. Instead, they entrusted the empire's fate to the laws of gravity and the strength of steel. Each multi-ton block of travertine was meticulously fitted to the adjacent stone without mortar. Then they were fastened together with internal iron clamps that were completely invisible from the outside. Deep grooves were cut into the stones in advance, into which thick steel brackets were inserted. After that, the entire joint was poured with hot, boiling lead. The lead cooled quickly and firmly locked the iron inside the stone block. In the end, more than 300 tons of pure iron were embedded into the body of the amphitheater. What looked like traditional stone masonry from the outside was in fact a flexible stone chainmail. But this internal armor concealed an even more complex engineering system. The illusion of strength was based on an invisible and mathematically precise distribution of enormous weight. The Colosseum is a dense forest of radial, load-bearing walls and arches. The arch was the ideal physical machine of all antiquity. It takes the dead weight of the stone above it and skillfully redirects it to the sides and downward. All this load went directly into powerful and stable supports.
The structure combined concrete floor vaults with brick interior partitions.
Heavy travertine columns were also used there for primary support. Different materials had different densities and varying degrees of flexibility. Thanks to this approach, the building literally breathed in response to external forces. It could safely contract and expand during sudden temperature changes without breaking. It was the ultimate illusion of technical success. But no architectural system can exist in an ideal laboratory vacuum. The grand opening of the amphitheater in the year 80 AD set in motion an irreversible process of wear and tear on all materials. The first and most formidable load on the building turned out to be human. 50,000 spectators regularly filled these stands. 50,000 excited bodies constantly shouting, stomping their feet loudly, and leaping up in a single, uncontrolled surge. For architecture, this is not merely a static, immovable dead weight. It is a rhythmic and very powerful dynamic vibration traveling through the entire structure. The impact of hundreds of thousands of feet on the stone steps was transmitted directly to the supporting arches and vaults. The amphitheater literally hummed during the bloody games, like a giant stretched membrane. The stone steps began to crumble into dust as early as the first decades of active use. But the supreme authority constantly demanded something more from the architects. The spectacles for the people had to become more complex, more unexpected, and on a grander scale. Emperor Domitian, who was Titus's younger brother, made a fateful architectural decision for the building. He ordered the arena to be dug downward, penetrating deep into the structure's very foundation. This is how the hypogeum was created, a vast two-level underground labyrinth. It was a dense network of chambers, dark corridors, and shafts for lowering wild beasts and scenery. Technically, it was an incredible marvel of ancient engineering for its time. The wooden floor of the arena concealed a highly complex theatrical and elevator mechanism beneath it. But from a physics standpoint, it was a fatal overload of the entire original system. Previously, the foundation had been solid, but now voids had appeared within it. Right in the center of the foundation, a huge void now gaped where a solid monolithic disc had once been. The central axis of the colossal amphitheater had lost its internal rigid support. The system began to operate at the limit of its original engineering calculations. The load on the structure began to be distributed differently than originally planned. The stress in the radial walls increased many times over after this work. The body of the building began to gradually accumulate the silent fatigue of metal and stone. Added to this was the constant and harsh climatic stress of the region. The Roman sun scorched the white stone during the day, and at night it cooled very quickly. Micro cracks crept across the travertine like an invisible and extremely destructive web. For a long time, the building was frankly lucky. Constant cosmetic repairs masked the ongoing wear and tear and minor damage to the facade. The Roman authorities closely monitored the condition of the arena, promptly patching cracks in the masonry. But large structures always have their own rigid physical limit of strength. In August 217, the sky over Rome suddenly darkened in broad daylight. A dry thunderstorm of incredible and terrifying power broke out. There was a heavy tension in the air, and lightning struck one after another right within the city limits. In this situation, the Colosseum proved to be a perfect an enormous target for the lightning. The tall, solitary ellipse towered over all the surrounding buildings. The building was literally laced with tons of metal reinforcement inside the heavy stone. On that day, the amphitheater acted as a giant lightning rod, drawing the most powerful discharge toward itself. Lightning struck the very top, the fourth tier of the structure, at tremendous speed. We've grown accustomed to thinking of the Colosseum as a completely invulnerable stone monolith. But its topmost tier, where women and poor plebeians usually sat, was almost entirely built of wood. There were long wooden benches and very thick wooden flooring for the spectators. There were also huge wooden masts there, which held up a canvas awning called a velarium. The fire from the lightning strike flared up instantly and began to spread at breakneck speed. Due to the building's immense height and the empty open arches, a powerful draft of air was created. The wind fanned the flames inside the corridors, as in a massive industrial blast furnace. Soon, the giant velarium itself above the people's heads burst into flames. Burning pieces of tarred ship's canvas began to fall down, landing directly on the wooden floor of the arena. For years, the arena had been soaked in machine oil, animal fat, blood, and dry sand. It burst into flames next, turning the center of the amphitheater into a veritable inferno. The smoke from this fire was visible for many kilometers around Rome. The flames engulfed the amphitheater simultaneously from above and from its very bottom. The temperature inside the stone bowl reached such extreme levels that the outer limestone began to literally calcine. The lead that held the iron clamps inside the stone blocks simply melted. It dripped down the building's joints in glowing, molten droplets. The heavy iron inside the stone quickly glowed red hot. According to the laws of physics, when subjected to intense heat, any metal inevitably begins to expand. The iron clamps, which were meant to hold the stones together forever, began to act like explosives planted inside. They expanded with tremendous force and relentlessly tore the heavy travertine apart from the inside. The sturdy stone blocks split in half with a deafening and terrifying artillery-like roar. When the fire, which had raged for many days, finally died down, the people of Rome saw, in place of the great arena, a blackened and charred ruin. The entire upper tier had been completely destroyed by fire. The stone throughout the building had developed deep and irreversible structural cracks. Attempts were made to restore the Colosseum after this catastrophe for nearly 40 years. But this was merely a desperate attempt at salvage, one that forever altered the very essence of the building. The original monolithic strength was irretrievably lost due to thermal shock. The metal inside the walls was thermally weakened, and the stone permanently lost its natural density. But the main and most devastating blow did not come from the sky at all. It was this blow that forever defined the Colosseum's current, strange, and asymmetrical appearance. This time, the threat came from beneath the ground, where it was least expected. The entire Apennine Peninsula is an active and highly dangerous seismic powder keg. Deep tectonic plates beneath Italy are constantly grinding against one another. This movement generates powerful and destructive underground waves that reach the surface. Any buildings constructed from hard, heavy stone inherently resist such horizontal vibrations. Stone structures simply cannot flex and are poor at dampening the resulting resonance. In 442 AD, Rome was once again shaken by a powerful earthquake. The Colosseum miraculously survived, but still lost a significant portion of its inner spectator ring. This was followed by new, powerful tremors in 470, and then again in 847. In the body of the aging building, fatigue in the materials, invisible to the eye, was constantly accumulating. Hidden microcracks slowly but surely penetrated the main load-bearing arches and columns. And then came the fateful year of 1349, which became a dark day in the monument's history. It was the year when the system, overburdened by centuries, finally could not withstand the external pressure. A shockwave of monstrous power swept through the very foundations of Rome. And it was precisely here that the geography of this site played its fatal role. That very point zero in the old swamp of Nero, from which all construction had once begun. The engineers of antiquity failed to take into account that the ground beneath the building was extremely heterogeneous. The northern part of the Colosseum stood firm and secure on solid volcanic tuff, but the entire southern part of the amphitheater rested on those very soft deposits of an ancient riverbed. When the ground beneath the city shook, the northern half of the building remained firmly anchored to the rock. It absorbed the shock and successfully withstood it. But the southern half of the Colosseum began to resonate dangerously at that moment. The soft, damp soil beneath the southern side behaved like liquid, unstable jelly. In physics, this process is called soil liquefaction under the influence of vibration. The massive southern facade began to sway back and forth with great amplitude. The structure could not withstand the resulting stress, and with a terrifying crash, broke away from the main body of the building. A colossal section of the outer ring crashed down to the ground with a thunderous roar. The impact raised clouds of centuries-old dust that obscured the sun for a long time. All that remained of the majestic wall was a shapeless mountain of broken stone and debris. This is precisely why the Colosseum looks so strange and asymmetrical to tourists today. On one side, we can still see the proud three tiers of the outer wall. On the other side, our view is met by the exposed interior and the stumps of stone corridors. The illusion of the Roman Empire's eternal durability finally collapsed that day. This collapse was no accident, but the inevitable logical consequence of its gigantic scale and a hidden geological flaw. After this catastrophic earthquake, the collapsed facade became the most valuable building resource in medieval Rome. The massive structure was no longer perceived by the inhabitants as a great amphitheater for spectacles. It officially and effectively became for everyone a gigantic quarry in the very center of the city. Every new salvation and subsequent revival of Rome exacted a fresh and very bloody toll on the Colosseum. The city urgently needed to build new, majestic Christian churches and cathedrals. The perfectly hewn, high-quality stone for these purposes was taken precisely from here, by dismantling the ruins. It was necessary to erect impregnable and luxurious palaces for the new urban elite and cardinals. All the necessary building material lay right at their feet. It only needed to be lifted and carried away. In those days, no one gave a thought to preserving the historical heritage of their ancestors. Architectural masterpieces such as St. Peter's Basilica, the Palazzo Barberini, and the Palazzo Farnese were built from this stone. The flesh of the ravaged and humiliated Colosseum is forever walled up within their ornate and sturdy walls. But the greedy medieval looters needed more than just smooth, beautiful stone. They were critically in need of iron, which was valued incredibly highly in those centuries. Those very steel staples, which Vespasian's engineers had carefully encased in lead for permanent fixation, became the target of looters. In the impoverished and harsh era of the Middle Ages, high-quality metal cost almost as much as pure gold. For decades, people methodically and purposefully drilled deep holes into the joints of the travertine blocks. They did this solely to pry out the precious steel and melt it down into weapons or tools. If you look closely at the Colosseum's facade today, you'll notice that it is literally riddled with deep, jagged holes. These are by no means bullet or shell marks from World War II, as many tourists believe. They are unhealing wounds from the chisels and hammers of medieval prospectors searching for metal. The building's entire internal metal skeleton was ruthlessly torn from its mangled and weakened body. The building was left standing completely without any supporting structures, exposed to the harsh elements. Now, multi-ton blocks of travertine remained in place solely by their own dead weight. Gravity, which had once been the builder's chief enemy, had now become the structure's only salvation. The amphitheater survived against all odds, yet it was rapidly losing its original engineering structure. It became completely open and transparent to all the Roman winds. Its once dark and majestic arches gradually filled with household trash, animal manure, and wind-blown earth. Over time, a whole wild botanical garden with rare plants grew inside the ruined amphitheater. The roots of these trees and shrubs slowly and inexorably tore apart the surviving ancient stone. The Colosseum turned into a melancholic and romantic ruin that attracted artists. But the harsh laws of physics never forgive the voids that form within a structure. By the beginning of the 19th century, it had become absolutely clear even to the most enthusiastic romantics. The Colosseum was dying. It became clear to everyone that the great building was preparing for its final and complete collapse. Deprived of the support of the collapsed outer ring, the remaining high walls began to lean menacingly outward. The laws of structural mechanics are always unforgiving toward damaged structures. A fractured stone cylinder in such a situation always tends to open up even further and eventually collapse. The exposed and jagged ends of the southern and northern fractures hung over the ground at a very alarming angle. Heavy stones began to fall regularly and suddenly from the old masonry, threatening passers-by. Pope Pius VII, realizing the full scale of the impending disaster, ordered that this historical monument be saved at any cost. The talented architect Raffaele Stern took on this complex and almost hopeless task. In 1807, he approached the eastern crack closely to personally assess the critical angle of the wall's inclination. Stern's solution was harsh and completely devoid of any architectural aesthetics. Yet it proved incredibly effective from the standpoint of precise structural engineering. He did not even attempt to restore the arches and elegant columns lost over the centuries. Instead, he built a solid and incredibly massive brick buttress that literally propped up the falling wall with its shoulder. This enormous brick insert became a support, preventing the building from collapsing completely. The architect simply froze the inevitable collapse at the very moment he found it. Stern ordered the outer original arches to be filled in with cheap bricks, turning them into a solid, blunt support. 20 years later, another architect, Giuseppe Valadi, repeated this same rescue technique on the opposite fault line. But his new buttress on the western side was executed with slightly more finesse. He built the supporting structure out of brick, yet attempted to visually replicate the shape of the original stone arches. The height of these new arches gradually decreased, creating a step structure. This was a completely new form for the ancient building, one that carried a hidden fragility. The Colosseum had forever ceased to be the self-supporting ancient structure the Flavians had created. Now it stood, and continues to stand, only thanks to these enormous, massive brick crutches. The restoration work significantly increased the visual and physical burden on the entire surviving monument. It turned into a sort of architectural Frankenstein, crudely stitched together from different eras. Noble Roman travertines stand side by side here with simple, utilitarian 19th century red brick. It was a truly brutal surgical operation on the body of history. It preserved the life of the building's old and battered body, but forever deprived it of its original purity of lines. The illusion of the integrity of the ancient world was definitively replaced by a harsh and necessary injection of construction pragmatism. The 20th century brought a completely new and extremely insidious threat to this great structure. The building could not have been physically prepared for such an impact under any of the ancient masters' preliminary calculations. Benito Mussolini was literally obsessed with the idea of imperial grandeur and holding large-scale parades. To this end, he ordered a wide thoroughfare to be cut straight through the city's priceless archaeological zone. The famous Via dei Fori Imperiali runs right up against the ancient and fragile walls of the amphitheater. From that moment on, a new phase of the monument's destruction began, one virtually invisible to the human eye. The modern load on the structure is no longer just the static dead weight of the stones. It is constant and destructive microvibration, as well as the aggressive chemistry of a big city. Thousands of cars speed past every day, and heavy tour buses create powerful ground vibrations. Later, a subway line was built deep underground, right next to the foundation. The Colosseum still rests with its southern side on soft, yielding alluvial soil. Because of this, it has begun to absorb man-made vibrations 24 hours a day without interruption. The low-frequency resonance from heavy urban machinery acts like a continuous and very slow earthquake. It mercilessly destroys the remnants of old lime mortar within the ancient masonry. The vibration causes the binding materials to lose their strength and literally crumble out of the cracks as fine dust. But far worse for the building than the physical shaking has been the modern corrosive smog. The exhaust fumes from thousands of cars constantly mix with the natural moisture in the Roman air. This reaction produces actual sulfuric acid, which settles on the walls. And travertine, by its very nature, is a porous and sensitive limestone. The acid enters into a direct chemical reaction with the stone's surface, triggering a process of decay. It irreversibly transforms its hard protective shell into brittle, easily washable gypsum. The once snow-white stone began to rapidly turn black and crumble under the influence of precipitation. The symbol of eternal Rome began to literally disappear at the microscopic level, right before the restorer's eyes. Every raindrop carried away a piece of its great and ancient history. The current condition of this building can be compared to that of a critically ill patient in a hospital. It is constantly connected to complex life support machines to maintain its integrity. The entire amphitheater is now tightly entangled in a network of invisible seismic activity sensors. High-precision laser reflectors are installed on its ancient walls. These devices record even the slightest millimeter-scale shifts of the heavy blocks in real time. A large-scale and very expensive cleaning of the exterior facade was recently completed. The centuries-old black soot was finally washed off the stone, and it once again looks cinematically white and clean. But it is important to understand that this was merely an expensive cosmetic procedure designed to attract tourists. Inside, in its true physical essence, the Colosseum remains extremely vulnerable and severely worn down by time. It exists today not at all as the original ambitious project of the Flavian dynasty. Now it is a highly complex, modern engineering infrastructure designed to support the falling stones. We see only the outer shell, behind which lies an endless struggle for every extra year of existence of this great ruin. Look at this perfect arcade against the backdrop of the blue Roman sky once more. You do not see the triumph of ancient thought. You see a highly complex system that has been broken by overloading, torn apart by earthquakes, plundered by people, and crudely propped up with bricks. At best, half of the stone shell remains of Vespasian's original monolithic design. And even that stands today in spite of the circumstances, not because of them. Modern skyscrapers made of high alloy steel and glass last far less. They are designed by economists with a clear calculation for 50, at most 100 years. They are not built to last forever because they lack overwhelming mass. The Colosseum has not collapsed yet only because it was built with a cyclopean, irrational excess of density. External stability is almost always illusory. All large systems have their own rigid physical limit, and the Colosseum reached its own 1,000 years ago. Power and ambition carry a colossal weight, measurable in tons, capable of crushing even the hardest rock over time. This symbol of the empire has survived, but the price of its salvation is measured in integrity lost forever. Its true history lies hidden beneath the surface, in a 13-meter-long invisible concrete anchor, in the empty, round sockets left by torn-out iron, and in the ugly 19th-century brick supports. Yes, it has indeed survived earthquakes, devastating wars, and the passage of time itself. But it stands before us not as a proud monument to absolute power. It stands as a heavy, scarred monument to resistance.